Welcome, AP Environmental Class Period 6. Today we'll discuss the importance of coral reefs in our aquatic system and how they're being affected and why they should be protected. As some of you may have seen, coral reefs are turning white, or bleaching, as some people say. Now, while this effect can be seen as beautiful, it's actually very sad. These white reefs are the endoskeleton of a creature that once lived there. In other terms, these skepticals are bones. Now, bleached corals are not dead, but transparent, and at more risk of starvation and disease. Now, with this information, there are a lot of questions that can be posed. Why are these reefs dying? Is this irreversible? And most importantly, what can we do to help? Now I bring it over to Brad to help with some of these questions.
When corals are stressed by changes in conditions such as temperature, light, or nutrients, they expel the symbiotic algae living in their tissues, causing them to turn completely white. According to the NOAA, coral and algae depend on each other to survive. Corals have a symbiotic relationship with microscopic algae that live in their tissues. These algae are the coral's primary food source and give them their color. If the coral is stressed, the algae leave. Without the algae, the coral loses its major source of food, turns white and very pale, and is more susceptible to a disease.
Thank you, Brad. There are multiple ecological causes to the bleaching of coral water. Increased ocean temperature caused by climate change is the leading cause of coral bleaching. A temperature increase of just 1 degree Celsius for only 4 weeks can trigger bleaching. Another cause is storm-generated precipitation that rapidly dilutes ocean water. The runoff can carry pollutants that bleach near-shore corals. Thirdly, when temperatures are high, high solar irradiance contributes to bleaching in shallow water corals. Exposure to the air during extreme low tides is another cause of bleaching in shallow corals. The Earth's climate warming also forms the problem of positive feedback loops. Positive feedback loops accelerate a temperature rise, whereas negative feedback loops slows it down. In the Arctic, the warming Earth melts sea ice, which then exposes more dark ocean, creating a lower albedo. Lower albedo means less heat is reflected off the Earth's surface, and with less albedo, more ice melts, creating a continuous cycle. This causes the ocean to absorb more heat.
Now we bring it over to Professor Terry Hughes at James Cook University in Queensland, Australia. Hello, Terry Hughes. Now, where are the most major bleaching of coral reefs occurring?
There have been 4 major bleaching events on the Great Barrier Reef since 1998. 1998 was the first one, followed by 2002, and now 2016 and 2017. 2 of those years, 98 and 2016, were El Nino years, where the temperatures are expected to be a little bit above average, but the other 2 were not. And that's a pattern we're seeing increasingly around the world. So historically, since bleaching events began at a regional scale in the 1980s, they've been linked to unusually hot El Nino summers. But increasingly, in the last decade in particular, we're seeing more and more bleaching events outside of El Nino periods, in other parts of the so-called ENSO cycle, even in La Nina periods, which are a little bit cooler. And the reason for that is that El Nino temperatures today are actually warmer. La Nina temperatures today, which are slightly cooler than average, are actually warmer now than La Nina temperatures were, El Nino temperatures were, 30 or 40 years ago. So all phases of ENSO cycles are warming through time over the last few decades.
Is the warming of the ocean the only concern when it comes to the bleaching of coral?
It's very clear now from the last couple of record-breaking summers that the main threat is global warming, and by the time ocean acidification were to become a problem at the end of the century with unfettered greenhouse gas emissions, most of the coral reefs of the world would be dead because they can't deal with the temperature.
The temperature would have
taken, so the immediate threat is temperature. There are other issues like rising sea level, which can affect reefs, but frankly it affects people a lot more than reefs, with coastal inundation and issues like that than any threat to the corals. Another issue is severe weather events, cyclones and hurricanes, which can be destructive to corals, but equally they're destructive to people.
Now, are there any other variety of coral that you can expect to fulfill the ecological void in the coral reef system?
We've already seen a change in the mix of species because some survive better than others. When coral recovery takes place, you see a different mechanism also causing a change in the mix of species. So the ones that are quick to recolonize a reef, the ones that breed better, the ones that disperse better, that travel from one reef to the next, the ones that grow faster, they'll be favored over the next few years. So we'll see 2 kinds of filters happening, a filter on the way down, if you like, and a different filter on the way up. So the mix of species is changing very quickly.
Now, how do you plan to inform the science behind coral reefs and create policy that is worth it for the average consumer? And how do we secure the future for these reefs?
The challenge is to sustain coral reefs that are functional, that deliver to societies the benefits that we currently get from it. And bear in mind that most coral reefs are in relatively poor, small developing countries, much smaller than certainly Australia or Saudi Arabia, that don't have the wealth of either of those two countries. For those small developing countries, coral reefs are absolutely critical for food security and for income from a global coral reef tourism industry. Even in Australia, tourism on the Great Barrier Reef is a $5 billion industry, and it employs 65,000 people. So that's an economic and a political reason for sustaining those natural resources and the benefit they provide to us.
Thank you, Terry. According to NASA, the Earth's oceans have absorbed 90% of the warming that has occurred in the recent decades due to an increase in greenhouse gases. Just the top few meters of the oceans store as much heat as the Earth's entire atmosphere. The amount of heat accumulating in the Earth's ocean is equivalent to 5 to 6 Hiroshima atom bombs of energy per second, 24 hours a day, every day of the year. So much heat that it has to be measured in zettajoules. As everyone knows, the Earth is warming, and it's caused by drastic amounts of greenhouse gases polluted by humans, but especially CO2. The ocean's average pH should be around 8.1, which is basic, but as the ocean continues to absorb more CO2, the pH decreases, which makes the ocean become more acidic. Ocean acidification slows the rate at which coral reefs generate calcium carbonate, thus slowing the growth of coral skeletons. With all this information, we can deem that coral reefs are clearly important to culture, economy, and most importantly, our ecosystem. Now, some people wonder if this bleaching happens naturally. And yes, it does, but the intensity and the rate that is happening right now is worrying. With this being said, the prevention of bleaching is a tough challenge, but it's important to work on. Countries like Australia and Belize are actually working on coral restoration and protection as we speak. Now, regular individuals typically can't have such a hands-on approach, so you may be asking how you can help prevent bleaching. The main thing you can do to help coral bleaching is to bring down your carbon footprint and help lessen the effects of the warming in the globe. Now, here are some memes from our team to help bring awareness to global warming and the coral reefs. Thank you, and save coral reefs.